Hi everyone, we're finishing up lesson 18 on binomial distributions, but we took a detour towards Pascal's triangle, which is one of the most beautiful things in math. I talked mostly about it last time, but I wanted to add in a few finishing touches here. This is a handout I created about the magic of Pascal's triangle. So as a quick reminder, remember we put ones along these edges of this tent or pyramid here, right? And every time we get two consecutive numbers, they give birth to their sum. Their sum is a sum. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, and so forth. And I claimed that these numbers in Pascal's triangle were in fact these binomial coefficients, these numbers of combinations, n choose r. So for example, 3 choose 1 is 3. And that corresponds to the number of ways for a Plinko chip to hit the 3. There are 3 drops, n equals 3, drop, drop, drop. Okay, a right is a success, a left is a failure. So how many ways can you get one success out of 3 trials? One right out of 3 drops? Well, left, left, right, left, and right, left, left. 3 choose 1 is 3. Now, how is this related to the binomial theorem from algebra? So you might remember from algebra class that a plus b all to the third can be written like this, right? Where for the variable parts, we start with a to the third, we decrease the exponent by 1 until the a disappears, and then for b starts off as b to the 0, which is 1, which is invisible, and then we get b to the second, b to the third. And the coefficients for this power of a binomial, right? These coefficients come from Pascal's triangle. It's these binomial coefficients, these n choose x guys. N choose 0, n choose 1, n choose 2, n choose 3. 3 choose 0 is 1, 3 choose 1 is 3, 3 choose 2 is 3, 3 choose 3 is 1. Now, why does that make sense? How do we get the cube of a plus b? Well, if you cube anything, you take 3 copies of that thing, here a plus b, and you multiply them together, and you can distribute like crazy. But basically, when you perform the distribution, for each term, you get a choice from here, a choice from here, and a choice from here. It's kind of like if you have 3 meals in a day: breakfast, lunch, and dinner. For breakfast, you can pick super salad, A or B. For lunch, A or B, super salad. For dinner, A or B, super salad. Okay, now again, instead of salad, we can talk about B, or a success, or getting a question right, or getting ahead. Okay, so basically, if you choose a term from here, and then choose a term from here, and then choose a term from here, there are 8 ways to do that. 2 times 2 times 2. 2 to the third is 8. So you could have all soup, right? A. That could be all failures. The number of ways to get 0 successes out of 3 trials. The number of ways to get 0 questions correct on a 3-question exam, 1 way. Wrong, wrong, wrong. A is wrong, B is right. But how many ways can you get 1 question right and 2 questions wrong? How many ways can you get 1 success out of 3 trials? Well, you could have wrong, wrong, right, wrong, and right, wrong, wrong. When you add these together, you get 3 a squared b. The 3 here is the number of ways to get 1 question right out of 3 questions. Likewise, 3 choose 2 is also 3. That's from symmetry. The number of ways to get 1 question right out of 3 is equal to the number of ways of getting 1 question wrong out of 3, or 2 questions right out of 3. So there are 3 ways to do that. You add these up, and you get 3ab squared. These 3 guys here. And then there's only 1 way to get all 3 questions correct on a 3-question exam. Correct, correct, correct. That's b cubed. Add these all together, and you get the expansion of the cube of a plus b. So if you love algebra, I'm sure you love that. Okay, so how do we use these ideas to figure out binomial probabilities? It's all related. The binomial theorem, right? These binomial coefficients and binomial distributions with their binomial probabilities. So for example, if you have a student taking a multiple choice test with 5 questions, n equals 5 trials or questions, and each question is A through F, 6 options, and the student guesses randomly on each question. The student knows nothing about the material and guesses randomly. So the probability of getting any given question correct is 1 out of 6. Let X be the number of successes, the number of questions the student answers correctly from guessing randomly on this test. The possible values are 0 through 5. The student could get all the questions wrong, 1 question correct, 2 correct, 3 correct, 4 correct, or all 5 correct. And here are the corresponding probabilities. But how can we figure out these probabilities? Again, this is optional for the homework and the exam, but it's good to see. All right, well, you could have software or TI graphing calculators. You could have printed tables, or the old school way of doing it, the binomial probability formula. The probability of X successes equals N choose X, or NCX. That's a binomial coefficient. Like 52 choose 5 was the number of 5-card hands you can get from a deck of 52 cards. N choose X, or NCX, is the number of ways that a student can get X questions correct out of N questions. So for example,